This is how the moon formed. Earth formed 4.54 billion years ago, but the moon is slightly younger. The most compelling theory we have is that a body the size of Mars, known as Theia, collided with Earth 4.5 billion years ago. NASA estimates this collision was 100 million times larger than the event that wiped out the dinosaurs. This is like a single cell compared to the entirety of the human body, or a grain of sand compared to the size of a mountain. Debris was flung into space, but the effect of gravity meant that these particles started to collide together to form the moon. Heat and pressure from these collisions meant the early moon was in a molten state. During this time, the moon was closer to Earth, and as the moon was essentially an ocean of magma, tidal forces from Earth's gravitational pull deformed the moon into the ellipsoid that we see today. As with the Earth, the moon separated into layers as it cooled. Crystals started to form out of the magma, and dense crystals like pyroxene and olivine started to sink, but lighter minerals such as plagioclase started to rise, and this plagioclase forms the moon's crust. We know that the moon was at least partially made from Earth's rocks, as basaltic rocks from the moon's mantle have a similar composition to rocks from Earth's mantle. It has been shown that oxygen isotopes from moon samples correlate very accurately with oxygen isotope signatures from Earth samples. This is our best evidence for a Mars-sized collision theory. So why do we get light and dark spots on the moon? So from Earth, we can see that the moon is composed of these lighter and dark patches. This is because the moon's crust is composed of the lighter lunar highlands and the darker lowlands of the lunar mare. The floating plagioclase crystals produce the rock known as anorthosite, which is abundant in the lunar highlands, giving it its light colour. The widespread presence of anorthosite, which forms as a creme brulee layer that floats on the magma, supports the idea that the moon was once a magma ocean. And further evidence for this was provided in a publication in August 2024, which showed that there was evidence for magma oceans near the moon's south pole, meaning that it extended across the celestial body. But then why do we get the dark spots? Well, the answer lies in volcanoes. Yep, the moon was once volcanic. 3.9 billion years ago, there was a huge bombardment by large asteroids, producing impact basins, which are depressions on the moon's surface. Magma rose from the moon's interior, filled the basins, and crystallized, producing these dark basaltic igneous plains that make up the lunar mare. These are mostly located on the side of the moon that faces us, hence why we see the light and the dark on the moon's surface. By looking up at the night sky and seeing the moon, we are not just gazing up at a celestial body. We are admiring our protector, our shield from asteroids. And researching the moon is like retracing the steps of our own planet's history. The more lunatics, the better.